Okay, Bismillah. Okay, folks, welcome to Trigonometry. We're going to be looking today how we work out sides and angles in right angle triangles. Okay, here we go. Right, let's get started. Well, one of my favorite programs is Paint. Trigonometry. Okay. Let me put that down, and today's date is irrelevant for the video, but anyway, 29 of the 8 of the 14. Okay, now we're looking at question number 1, Maths Watch Grade B, clip 147. Okay, you don't have that sheet in your homework diaries for, I don't know, for whatever reason. You just follow from here for the moment. You've got lots of additional exercises. You've got the CGP work in there and Rainer work. Okay, yeah, I can zoom in. So first we'll just show you the title and everything else. Now we're going to zoom in a bit. Okay, let's make it a bit bigger. We're going to look at BC and make it a little bit more bigger. Okay, this is the question here. And in this question we need to work out BC. So what we'll do, we'll highlight that.
You have to draw it.
Yeah, draw the quick sketch of it. Sketch. So you don't need to use a ruler or anything else. So we've got to work out this length here, BC, in this diagram. Oh, I can't even see that bit there. Let's get rid of that. That's not good. So we've got to work out that side there. So we have to work out in this question the length BC. Okay, just quick question. Okay, lovely. Right, first thing we're going to do, we are going to label the diagram. And this is how we label the diagram. Opposite the angle, now listen to my language, opposite the angle is called the opposite. So that's a bit of a no-brainer, is. Opposite the angle is the opposite, and put a big O for the opposite side. O for opposite. Now, opposite the right angle is always the hypotenuse. And the hypotenuse is always the longest side of the triangle, of the right angle triangle. Now, we label the opposite first, or the hypotenuse first. That always leaves you at the end with one remaining side, which is called the adjacent, which we label as A. Okay? Now, if we look at the question, our question is linked with, so let me just change it to, we have, it's connected with the hypotenuse, because we know the hypotenuse, and we need to work out the BC, and it's connected with the adjacent. So this is the two pieces of information that we know, and also we know the angle. So I'm just circling the information that we know. So we know these two, the hypotenuse, we know the angle, and we want to work at the adjacent. So this question connects the adjacent and the hypotenuse together. Okay, now, let's quickly write down our rules for trigonometry, is what we use to help us do the question. So we use, what do we use to help us do the question? So, so this is a tool that we use to help us remember the order of the calculation. Now the sub represents sine. Okay, I don't know why I'm using that. I should be using my brush. Okay, so sine of my angle is equal to the opposite divided by the hypotenuse. That's what stands for. Sine O over H. So this is called a trigonometrical identity. So that is the sine one. Next we have the cos. Okay, so we say cos, which stands for cosine of the angle, is equal to the adjacent divided by the hypotenuse. That's a second trigonometrical identity. Oops. Okay, and the last one is the TOA. TOA is represents, so we got tan of the angle is equal to O over A. So this is a quick revision of what these are, this shortcut here stands for in reality. Okay, so we mentioned that once and then we can just use it after that. Now, in our question, we said we had our question connecting A and H. So when we look at our diagram, we can see that A and H are in which identical, no, wrong one, wrong color. And A and H are in which one? In the cap. So we're going to be using in this particular question, what we're going to be using. So we know the angle, so it's called, we know the cos of the angle, and we know the hypotenuse, and we don't know the adjacent. This is called the two ticks and one cross. So we know two pieces of information and we're missing the third one, and that's a good situation to be in where we only have one unknown. So we're going to be using this identity here, the cos one. Okay, what I'm going to, okay, so I'm just going to say that we're going to be using this for this question. Now, that is the original identity. Now, we actually use this in a formula triangle. Have you familiar with the formula triangle version? That would be easier for you to actually do the calculation. So I'm just going to rub this off for the moment and write that down. So I'll show you a different way of looking at that question. Okay, let's get rid of that. Okay. Okay, so I've had to clear the page for just a bit of technical problems with the software. Now we say we're going to use cat. So this is one way of writing it down. This is the formula triangle way, and we use. Okay, here we go. All right, let's get some lines. So we have. Okay, I want to draw another line. Oh. Okay, all right. Okay, that's lovely. Okay, folks, so this is what we use, a formula triangle. So there's a cap. Now, what we do here, we need to cover what we need to work out with our thumb. So we need to work out the adjacent. So we cover up the adjacent with your thumb or your finger, and that tells you what to do. So the adjacent we don't know. We do know the angle, and we do know the hypotenuse. So to work out the adjacent, what we say here now is, so the formula triangle helps us to it tells us exactly what to do. So the adjacent A, which is equal to BC, is now equal to all of this. Cos of the angle multiplied by the hypotenuse. So let's work that out now. Let's put some values in there. So we are now going to do cos of the angle. What is the angle? The angle is 24 degrees. So cos of 24. Okay, are you folks writing it down by the hypotenuse, which is 50. So it's calculator time. First we on the calculators. Let's get our calculator. So we have cos 24, close bracket. Okay, right, hang on a second, let's just, why am I not, I should be in math mode. Well, that's actually matrices. Okay, 1 second, let's pause that. Okay, so we're doing cos of 24 angles, then times it by the 50 as you see here. That gives us an answer. So the answer on the calculator gives us 45.677 to something blah blah blah. I've written down those numbers. Now, if you look at this question over here, we have 50 centimeters. Okay, the question, I'm just going to quickly check what accuracy they want in the question. Correct to 1 decimal place. Okay, so we need rounds up to 1 decimal place. So, red please. Okay, here's the first decimal place. Put a line down here. This is called my last digit. This is my decider digit. If the decider is 5 or more, we add 1. And it is 7, so which is more than 5. So the answer will be 45.7 centimeters is the length of BC using the cos cap part of the Sokotoa. Okay, you happy with that? Good. That is one way we're working out length. The next question we're going to be working out an angle. I'll show you how to do that. Has everybody copied that down? First of all, from the board, yeah? Into your books. Good. Happy? Let's move on to the next question. Okay, in this next question, we're going to be working out an angle. Okay, sounds familiar to angle, but it's completely something different. Okay, so we're going to be working at angle X. Okay, Mr. Hassan, you got that? You happy? So, I've highlighted that. Can you quickly do a sketch of that diagram for me, please? So, right angle triangle, sketch of it. Now, let's label this diagram first of all. So, let's go to this one here. So, we say opposite the angle. The key word in the language is opposite the angle is called the opposite, of opposite. And then we say opposite the right angle is always the longest side, which is the hypotenuse. Okay. So, this is what the opposite is equal to. This now that leaves one side left. So what side is that? That is called the adjacent. Okay, let's have a look at what we know in this particular question. So we know in this question, we know the hypotenuse, we know the opposite. Let's for a line to connect those two pieces of information, but we don't know the angle. So we're not, even though we don't know the adjacent, we're not looking for the adjacent in this question. Remember, what we're trying to work out is the x. Okay, now we have O and H. What sound does O and H make? It makes sound. So we have sa, ka, toa. So this is going to be which identity? The sign sah one. So it's the sign one. So let's write that out over here. So we have S this is our formula triangle, sine of the angle, opposite, hypotenuse, sah, and then you have cat and toa. So this is the one we're using. Why are we using this one? Because we know the opposite, we know the hypotenuse, but we don't know the actual angle here. We don't know the angle, which is represented by x. So this is the part that we don't know. So we have two ticks and a cross. So what we do now, as we said before, we get our finger or our thumb and we put it over this part of this equation here, this formula, and that's our finger, and that's how we work out the sine of the angle. So sine of the angle is equal to O divided by H. So it's telling us what to do, it's helping us. So we can write that down now. So we can write down now sine of my angle is equal to opposite divided by hypotenuse. Now, we want to work out the angle. This is the theta symbol to represent angle, which in our question is actually referring to the x. So you can replace it with the x if you like, that's not a problem. Now I want to work out this. In this equation I have sine of the angle. I don't want sine of the angle, I want just the angle. So what do I need to move? We need to move over what? The sine is acting on the angle. So the opposite of sine on the left hand side is inverse sine on the other side. So I'm just going to write it a bit more neater now and clearer. So actually I'll need some space. Will we fit in here? We should. So theta is equal to, okay, Okay, now where do you find this button sign -1? You find it on your calculator by pressing shift and the sign button. So now we need to now put the values in. So let's put some values in there. So we have sign of -1. Oh, what's the O value? The O value is, what is it? 8.4, and the H value is? 18. So we got 8.4 divided by 18. We can put a bracket there just to make it a little bit more nice and easy for us to deal with. And we can keep the color scheme running so we know what we're doing. Okay, now we need to put this into the calculator. Let's get the calculator out. Okay, so we're going to type in now, so it's shift, sign -1, brackets. Okay, I'll use the fraction button, so we put 8.4 on the top. Press replay, bring to the bottom, and we have 18 on the bottom. Press replay to bring the cursor back up, and then we close the bracket. So what we see here, at the bottom of the screen over here, what we see here is exactly what we see in the screen. So most of you should have those kind of calculators, and then we press equal, and that gives us an answer of? What's the answer of? What answer do you have in your calculators?
27.818.
Okay, I'm just gonna write this answer. Over here. Okay, so we can say, because I'm running out of space on the bottom. Now remember, the theta in our symbol here is represented by the angle x, which is over here. Oops. Okay, so that is now equal to another. This is also to 1 decimal place answer. Let's copy down what we got there. So we got 27.81818. Now, when we're going to be doing this to 1 decimal place, we're going to stop here. We look at this number here. If this is 5 or more, we add 1. It's not 5 or more. So the final answer is going to be 27.8 degrees is the answer for x to 1 decimal place. And that is our final answer for this question. So if this number was 5 or more, we add 1. Because it's less than 5, we leave it alone. And that's the answer to 1 decimal place. And that is how we work out an angle. Okay, folks, are we happy with that? I'm going to release you on some questions now for you guys to do.
But we're not doing the tower.
No, that's giving you one example of a side, one example of an angle. Yeah? So that's just another angle question. Yeah, so you're going to have to practice that yourself, that's no problem. For now. But if you want to have a look at, we do have more videos on YouTube on trigonometry from the previous year. So you can have a look at more questions. Okay, but for now, for this lesson, that's what we've got time for at the moment. Okay, I'm going to stop it here. Are we ready to do some questions, folks? Yeah?